You know, the ESP32 is an absolutely incredible platform, but starting a new project, it can honestly feel like you're standing at a major crossroads. Which chip should you pick? What software are you going to use? These decisions you make right at the beginning can literally make or break your entire project. So in this explainer, we're going to decode the whole ESP32 ecosystem and give you a clear map for whatever you're about to build. It always starts with that spark, right? That one cool idea. Maybe it's a smart sensor for your garden, a custom display for your desk, or maybe it's the next big thing in home automation. You've got the concept, you're ready to get your hands dirty, but what's going to be the brains of the operation? Well, for literally millions of makers and professionals out there, the answer is the ESP32. It's an absolute powerhouse on a tiny little chip packing in Wi-Fi, Bluetooth, and a lot of the time dual-core processing power. It is the go-to choice for a very, very good reason. And that right there brings us to the central challenge. See, the ESP32 isn't just one chip, it's a whole family of them, and programming it isn't a one-size-fits-all kind of deal. The choices you make right now about the hardware and the software are going to shape your entire development journey. Okay, so your first major decision is all about hardware. Are you building something that needs to crunch a ton of data and drive a fancy display? Or is it something that needs to just sip power while speaking all the latest wireless languages? This is the core trade-off we're looking at: pixels and processing versus protocols and power. To make this super simple, let's look at two of the most popular modern options, the ESP32S3 and the ESP32C6. I want you to think of them as two different specialists. The S3, that's your compute and vision workhorse, built for the heavy lifting. The C6, that's your modern connectivity king, the master of communication. The ESP32S3 is all about raw performance. It's got two high-speed cores and these special vector instructions that seriously speed up machine learning and signal processing. So if your project involves a screen, a camera, or any kind of smarts happening right there on the device, the S3 is what it was built for. The ESP32.C, on the other hand, is a total connectivity prodigy. It's one of the first in its class with Wi-Fi 6, and, this is critical, it has a built-in radio for both Thread and Zigbee. This makes it the perfect choice, the future-proof choice, for smart home devices that use the new Matter standard. And when you put them side by side, this is where the trade-offs become crystal clear. Look at the CPU. The S3's dual cores give it roughly double the raw performance of the C6's single core. But then you look at the radios, and the story just flips. The C6 has Wi-Fi 6, which is amazing for crowded networks, and it has that dedicated radio for Thread and Zigbee, something the S3 just plain doesn't have. So let's break it down. You're going to pick the S3 when your project is all about its computational needs. If you're running heavy machine learning tasks, connecting a camera, driving a display, the S3 is your chip. It's also got USB on the go, which is super flexible, and a ton of GPIO pins for connecting all your sensors. But if your project is all about communication, especially in the modern smart home, the C6 is the clear winner, no question. It's designed from the ground up for low-power, super reliable connectivity using the latest standards like Matter. Think smart plugs, sensors, and light bulbs that have to last for years on a single battery. All right, so you've picked your hardware. Awesome. But now you hit that second crossroads: software. How are you actually going to program your chip? And here, the choice really boils down to one thing: simplicity versus control. The two main paths you can take are the Arduino IDE and Espressif's own framework, the ESP-IDF. Now, Arduino is famous for being incredibly simple. It's perfect for beginners and for getting a prototype up and running fast. ESP-IDF, though, that's the professional-grade tool that lets you unlock every single feature of the hardware. Let's take the classic hello world of hardware: blinking and LED. In the Arduino IDE, the code is just beautiful. It's simple. You've got a setup function that runs one time and a loop function that just runs over and over forever. It's clean, it's intuitive, and millions of makers already know it. It just works. Okay, now let's look at the exact same task, but in ESP-IDF. At first glance, it looks way more complex, right? You're including headers for FreeRTOS, which is the real-time operating system running underneath. But look closely. That delay function is now vtask delay. And this is huge. The Arduino delay function freezes the entire processor. But vtask delay, it only pauses this one little task, letting other critical things like, handling the Wi-Fi connection run smoothly in the background. That, right there, is the power of control. And look, this isn't just some academic debate. This choice has massive real-world consequences. Just take a look at ESP Home, which is this hugely popular platform for smart home devices. As they pointed out themselves, after years of adding more and more features on top of the simpler Arduino framework, their software had become, well, bloated. So this realization led the ESP Home team to make a monumental change. They decided to switch their default framework for all new ESP32 devices away from Arduino and over to the more complex but way more efficient ESP IDF. This was a massive undertaking, but as you're about to see, the benefits were absolutely undeniable. So what were the results? Staggering. By moving to ESP IDF, ESP Home saw up to a 40% reduction in the final size of their firmware. For devices that have limited flash memory, that is a total game changer. And not only that, but their compile times got faster too, which streamlines the whole development process. So what does a 40% smaller file size actually mean? Well, it means devices that were completely full can now get new features. It means better performance because the code itself is more optimized. And maybe most critically, it means that devices already out there in people's homes can be supported for years longer, which is a huge win for sustainability. I think the ESP Home team put it perfectly. This move wasn't just about a performance boost. It was a philosophical shift. It was about making sure that progress didn't mean users had to constantly throw out their old hardware. It was about building a more sustainable and durable ecosystem for everyone. So, with all of this information, how do you choose your path? It might seem a little overwhelming, I get it, but there's actually a really simple and practical way to get started. Here's the most effective path forward, in my opinion. Start with the Arduino IDE. It is the absolute best way to get your idea up and running quickly, to test your sensors, to just understand the basics. But once your project starts to get serious, once you need real multitasking or optimized performance or a structure that can actually scale, that's when it's time to make the leap to ESP IDF. At the end of the day, there's no single best choice here. The S3 isn't universally better than the C6, and ESP IDF isn't always better than Arduino. It is always about picking the right tool for the job that you need to do. So now that you've got the map, the only question left is, what are you going to create?